Good morning, boys. I hope you're well. We are looking at compound interest today. Last lesson, we were focusing on interest and simple interest. Remembering interest was that little bit extra amount that we either had to pay back if we borrowed something, or we got paid in return if we lent it to someone else. Is that fee, I guess, that you might have to pay or you get back extra. So basically, simple interest we know is always based off the original amount. So we use that example, we can use this example today where we're borrowing $1,000. Actually, we're investing $1,000 at 10% for 3 years, which means if I look at the first year, let's call it A1, we get 10% of $1,000, which is $100. After the second year, we get 10% of $1,000, we get $100. After the third year, we get 10% on the $1,000, which is $100, which in total, of course, means we get $300. Now, of course, you probably wouldn't do it that way. You probably look at me thinking I'm an idiot. I'm not an idiot, but I'm just showing you something for the next question. You'd say, sir, wouldn't you use I equals power n? You could just times the $1,000 by the 10% and times it by the number of years, because that $100 will be the same every time, which means we automatically get the $300, and I would say absolutely spot on. However, I want to look at the next process for compound interest. What does compound mean? Because let's say, for example, if you're trying to save some money, right? So you're investing that money, there's a bit of a rip-off, right? Because at the end of the first year, you actually have $1,100, right? The next year, when you invest $1,100, you don't get the 10% on that $1,100. You get the 10% on the original $1,000, and that's a bit weird, right? Because let's say, for example, we'll look at the other flip of the coin. That first year, we get 10% of the $1,000, like we just said, right? That gets me $100. That means the next year, technically speaking, should we not get 10%, not of $1,000? But of $1,100, because that's actually how much money I have in my account. That would end up being $110. Now, the third year, should I now not get 10% of that? Well, let's add 110 to 1,100, $1,210. That would be $121. Now, in theory, if we weren't being ripped off, we should actually now have $331, right? But if I use simple interest, look at what I'm missing out on. I know it's only $31, and you're saying, well, it's not a huge amount, but if you start pumping money in, like you're investing $10,000, $100,000, or $1 million, you can start to see over a greater period of time, there's going to be a massive variance here between simple and compound. Now, of course, if you're borrowing money, you've got to pay it back. The simple interest is much nicer, but the banks are smarter, because the banks won't use simple, they'll always use compound, okay? Because they want to earn as much money as they possibly can. So, generally speaking, gents, we use compound interest mostly, and what it does, it's what it means. It compounds. If something compounds, it gets bigger, right? So it means at the end of the first year, your money gets calculated, okay, and then you earn interest on what's in that account. And then in the second year, it gets recalculated, then earn interest on what's in that account. Now, that's on a yearly amount. We can actually start playing around with the compounding period, because you don't have to do it just after a year. What if you calculated your interest after half a year, or after a month, or after a week, or after a day? If you calculate your interest more often, should you not be earning more interest as you go forward? It's a really cool concept. So we're going to look at this question. Now, of course, with that, we could actually come up with a nice little nifty formula. I'm not particularly too interested in how that formula is created at the moment. I'm going to tell you that the formula looks like this. Principal 1 plus r the power of n. Okay, that's the big one that you have to remember. Okay, sometimes in the advanced courses, even in actually standard maths now in year 11 and 12, they'll use these letters instead, which I'll explain to you. Okay, they mean the same thing. So we know that A means the final amount. Okay, the final or the whole amount. Principal is still the same. Rate is still the same. N is the only kind of different one. It's still the number, but it's not number of years. It's number of compounding periods, which we'll talk about in the next couple of questions. Okay, the only difference is for FV, this means the future value, final value, future value, it's what it's going to amount to. PV is the present value. Okay, and that just means what is it worth now, the principal amount. FV and PV are more financial terms that we use in the financial world, but we still do use it in this level of mathematics. You will still see it there. Okay. We'll then talk about depreciation later on, but compound interest means to get bigger, it compounds, which also can be spoken about as appreciation. So we're going to look at see how this formula works with these questions. Now, if you've done this before, you might want to scoot through and have a crack at these questions. The first one should be reasonably easy, but it starts getting a bit more challenging as we go through. So for all these questions, first of all, see how they have the word compounding in there. Otherwise, if there's no word compounding, it generally means it's simple interest. So when it says that recalculates at the end of each period or uses the word compound, we know we're using that compound formula. So I'm going to use the formula A equals P brackets 1 plus R the power of N. Okay, let's see how this works. So the first one says I invest $600 at 10% per annum for 3 years, but it compounds annually or yearly. Now, it's really important that these things have to be in the same units. If they're not, we have to be careful. We may have to modify them. But in this case, it's compounding annually and it's per annum. It's about the same thing, so I'm going to plug it straight in. A equals my principal of $600. I'm going to put my 1 plus my interest rate. I'm going to put it as 0.1, and to the power of n is the power of 3. Now, I prefer you putting the rate in as a decimal, but you can certainly put it as a percentage if you wish. No problems there. And then I'm simply plugging that into my calculator, and I end up getting the answer of $798.60. Now, some similarities, of course. Obviously, you're calculating interest, but from the simple interest formula, that interest formula was I equals P times R times N. You are calculating the interest first, where here, we're actually calculating the whole amount. Now, in this question, I haven't really asked a question. I should have said, calculate the final amount, and that would be the final amount. But what if it said, find the interest earned? Well, if I started with 600, I now have $798.60. The interest earned would be $198.60. So you still have to be careful about what the question's asking you to find. Read the question. Don't lose careless mistakes or make silly mistakes. Now, the next question for the monthly. This is where it gets a bit more challenging, because what happens, right? We're going to calculate it at the end of every single month, which means how many times am I actually going to recalculate this question? That previous question, we were doing it annually, right? Annually. So we did it 3 times. But if I'm calculating it each month for 3 years, I'm going to be doing this for 36 months. So 36 calculations by hand I'd have to do. The formula will allow us to do this nice and quickly. However, we have to be careful of a few things. So A equals, now I'm going to put my principal of $600. I'm going to put my 1 plus, my interest rate is still 0.1, haven't changed that. And it's for 3 years. But you could see if I did it like that, I would get the exact same answer to the previous question. But you might be yelling at me saying, sir, N is no longer 3, because now you're doing it for 12 times a year for 3 years. That's 36 times. I'm going to put a little times by 12 there. You can put 36 if you want. And that's correct. But it's still not correct, because what you're now calculating is you're doing 10% for a whole year. You're doing that 36 times. It doesn't really work out, because if I'm going to calculate it for every single month, well, I'm not getting 10% per month, am I? I'm getting 10% across an entire year. So if I'm timesing this by 12, guess what you have to do to the interest rate? You need to divide it by 12, because this and this needs to be in the same amount. So if you're saying I'm going to compound it for 12 months, I need to have this as a monthly rate, which means my rate is actually 10% divided by 12. Okay, makes it a little bit more challenging, I understand that. But what you'll start to figure out, if you're playing around with different compounding periods, if you change the n, you will generally speaking change the interest rate as well. Now, if I plug that into my calculator, we end up getting $808.91. I'm just going to make a little bit more room here if I can. I'm going to drag the quarterly down. I'm going to start losing room here in a moment. Okay, now, if I want to look at the interest earned in this question, okay, I'm going to have $208.91. Okay, you can see all of a sudden the difference between doing it, compounding it over a year, or at the end of each year, as opposed to at the end of each month. I'm starting to get a whole lot more money here. Now, these are no particular order, but I'm changing the compounding periods each time. So for quarterly, what does that mean? Well, it means that I'm recalculating it at the end of each quarter. There are obviously 4 quarters. We could say the end of 3 months, calculate it, 3 months, calculate 3 months, calculate 3 months, and calculate. Either way, if I start with that basic 600, 1 plus 0.1 to the power of 3, that's the basics. If I'm doing it for 4 times a year, that's what quarterly means, for 3 years, we're doing it 12 times. Or otherwise, we can see quarterly is 4 times a year, I'm going to times my n by 4. But of course, if I'm doing 10% over a whole year, I want it for just a quarter of a year, so I'm going to divide that by 4. I'm going to tap that into my calculator. I get $806.93. My interest, of course, will be $206.93. I did that quickly on my calculator previously. Now, what you can see, if I'm doing it per quarter, that's not as many times as doing it per month. And you can see the interest is slightly less than what I did for the monthly. So what you're starting to see, the more often or the more common you calculate, the more money you should actually get. I'm going to do all the different time periods that we are familiar with. Generally speaking, we probably deal with the first 4 regularly, not so much E and F, but I'll talk about that when we get to it. So what does biannually mean? Well, bicycle, 2, okay, annually, year, twice a year, okay? You can say it's 6 monthly. After 6 months, we calculate, 6 months we calculate, which means how many times are we calculating this interest across 1 year period? We're doing it twice in a year, which means 6 times over 3 years. So would you expect to get more or less money than the quarterly? Okay, well, hopefully you recognize you're probably going to get less interest because you're doing it twice a year as opposed from 4 times a year. So let's have a look at it. My basic amount is $600, 1 plus 10% to the power of 3. That's for everything in annual amounts, but we now put it in biannual. So we're doing it twice a year, which means instead of doing 10% over a year, we're now doing it 5% for half a year. So I'm going to divide it by 2. If you want to put 5% there, 0.05, you can put 5% over 2. I say 10% over 2, it's fine. 5%, up to you. I'm going to recalculate that now, and we end up getting $804.06, which gives me interest of $204.06, and that's slightly less than what we got for the quarterly. We expect that to happen. Okay, so again, whenever you get a question where the compounding is not the same as the rate, so compounding annually and percent per annum, you need to modify, okay? And in 5.3, that's where the questions will come, all right? You'll usually get 1 annual, but then most of it will be quarterly, monthly, biannually, etc. Weekly, we don't tend to use weekly all that often, but certainly we can use it. Okay, exactly the same thing. Hopefully you can do this on your own now. 1 plus 0.1 over. Well, instead of being twice a year, we're doing it 52 times because we're doing it at the end of every week. So we're going to do 3 times 52. And of course, you can always do the actual value, which would be, 156, something like that. Okay, I'm going to do that in my calculator very quickly. And we get $809.68, which gives me interest of $209.68. Now, because that at the moment is the most amount of times that we've done it, you can see we now have the highest amount of interest. I'm going to finish it off by doing daily. Okay, so A equals 600. I got my 1 plus 0.1 over, well, how many days in a year? 356, most years anyway. Okay, and then to the power of 3 times 356. Okay, chuck in my calculator, we get $809.88, which gives me an interest of $209.88, slightly more than the daily, but not a huge amount, the weekly, sorry. So I'm just noticing we're at 15 minutes. I'm trying to push this through a little bit faster. So in these questions, okay, I'm going to come back to this one here. Always look for that word compounding. If it's compound interest, we know we're using this formula here. Very, very important. If the percentage rate or the interest rate, percent per annum, and the compounding rate are not in the same format, we need to change them. And that often will mean timesing the number of years by something and the percent per annum by something. If I look at this last question, this is a bit more challenging. Let's just do it on the fly. How much should I invest if I want to make $1,000 at 10% per annum compounded annually for 3 years? All right, this is a slightly harder question. I consider the word compound. A equals P brackets 1 plus R to the power of N. Now, this is slightly different. It says, how much should I invest? Which means I need to find the P value. Well, that's different. I want to make $1,000. Well, that means if I want to make $1,000, actually, let's say, because that's a bit more challenging. Let's say I want to have $1,000. That makes it a bit easier. So $1,000 is what I want to end up with. Okay, I have my principal amount, which I don't know what that's going to be. My interest rate is 10% per annum and for 3 years. Now, it's compounding annually and it's percent per annum and it's in 3 years. So I don't need to modify anything like that previous question. It's all in all. So why is this hard? Well, it's not really that hard. It just means I want to find P on its own. What's in between the P and the brackets? It's a times. So I'm simply going to do divide. So 1,000 divided by 1 plus 10% to the power of 3. Now I'm just going to do that with my calculator because I haven't done that yet. So I'm going to type in my 1,000. You can use the fraction or you can simply put divide. I'm going to put my brackets. My 1 plus 0.1 or 10% is fine as well. And then all to the power of 3. Now I could make this question a bit more challenging by playing around with the compounding periods if I wanted to. And I end up getting P equals $751.31 to 2DP, and that will be my principal. Okay, so a little bit more challenging, but not too bad. Now, the only last thing I want to talk about is these two words. And apologies, I'm sweating a little bit. It is currently 41 degrees here. So we've got appreciation and we've got depreciation. So sometimes you'll get questions which doesn't use the word compound, but it says the price of a bottle of water has appreciated by 10% every year for 3 years. Appreciation means it gets bigger. So at the end of each year, we recalculate, gets another 10%, recalculate, gets another 10%, which means it is compound interest. So we are still using the A equals P brackets 1 plus R to the power of N. So it doesn't use the word compound, but it means compound. But what does depreciation mean? Well, it means to get smaller. It loses value. So a car, I might buy a car and every year it loses 5% of its value, which means that the first year was worth $100,000. I then calculate 5%, I take it off, I get my new amount. Work out 5%, take it off, get my new amount. That's exactly the same thing as what we've been doing, but instead of having a plus R, we have a minus R. Exact same formula, but it's just a subtraction. The great thing about these two questions, guys, is that you won't get the compounding periods being changed. It will always be annual. You won't get monthly or quarterly. It'll always be an annual amount. So you'll never have to play around with the N value or the R value. You just have to get the right formula. You plug it in, you get your answer, and off you go. Okay, guys, that is pretty much it. Remember, the two formulas you need to remember realistically, okay, for this stuff here is going to be, I've lost those two formulas. They're around here somewhere, weren't they? There they are. The A equals P brackets 1 plus R to the power of N, or the second version with the FV and the PV. And then, of course, if you're looking at depreciation, we have a minus instead of a plus. I hope that made sense. Have a crack at the questions. Have a wonderful day. I'll see you shortly.